Okay, so as we're learning to make good measurements, we talked about how making measurements is based on reading the device correctly, which means precisely to the correct placeholder, and obviously accurately. So you're like precision is reading it to the correct placeholder, and accuracy is actually like knowing what the marks go up by and then reading the mark where it is, and then including units. So what we're going to work through here, and you're going to want to practice as we're going along, is we're going to work through this in-class practice worksheet. So you want to have this note sheet either printed off or open up on your screen, and you're going to want to attempt to make the measurements before I do, and then check and see how you did, and then you can hear me talk through the measurements. So this is like the in-class how to make measurement note sheet. You can find it on Schoology or on our learning platform where it's directed for the assignment. So when you're making a measurement, the most important part is determining the scale, and we learned the step-by-step process on how to do that. Sometimes you can just look at a device and determine the scale, but if you need that systematic process, you can do that, and that's what I will model here. Once you determine the scale, which is just what the marks go up by, then the precision, determine the precision, that's always one placeholder beyond the marks, okay? So if the marks are going up by ones, then we'd estimate to the 0.1s. If the marks are going up by 0.1s, then we'd estimate to the 0.01, and so on. And then we're going to read the measurement, make sure it's accurate, and then include units. So on this note sheet, the first one that you have to mark is a ruler. And notice that it doesn't have units like somewhere on it. A normal device would, but we would just do generic units for when we're making this. So the scale here, if you want to do the systematic way, remember that you're going to pick two marked lines, all right? And I believe I picked 10 and 0. So it doesn't matter which ones, you just need to pick two marked lines and subtract them. Okay, so 10 minus 0 is 10, that's the first step. You then have to count how many lines there are. So the first line is always line 0, and then you count from there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, there's usually 5 or 10 lines. If you get a different number, then you probably counted wrong, and so just double check. So you count the lines between the two marks that you chose, and then you're going to divide, okay, the subtraction, okay? So you're going to divide the two marked lines by the number of lines, and then for this one we'll get 1. So this one, you know, you could probably figure it out that each marked line, like this marked line right here, represents 11, and 12, 13, 14. This one marks 15. So every marked line is going up by 1s. So the scale, that's what we just determined, is going up by the 1s. So if we do our little placeholder, so this is what we can see. Like that's the marks. The marks are right there. So our precision, we estimate here 1 placeholder beyond the mark. So every measurement on this device should end in the 10th place. Okay, so if we were making this measurement here, we're going to go 20, 1, 2, 3, 4, 5, 6, 7. It looks like it's in between 27 and 28. All right, we can see 27, we can see 28. I'm going to make that go away here, but we cannot, we have to estimate, you know, where is that mark? It kind of looks like it's closer to the 28 than the 27, and that's where we're making our best estimate, okay? So it falls between the 27 and the 28. I put 27.6, okay? Now, if you said 27.7 or 27.8, That's also fine. What's important is that you have 27 for sure. We're certain about that. And then we're estimating, we're doing our best guess to that precision placeholder. This is the placeholder we're the least certain about, but we're doing our best guess there, okay? So if you had put 27.7 or 27.8, that would all be within reason. And then since it doesn't say centimeters or inches or anything, then you just put units for generic. So that's how you make a measurement with the correct level of precision and estimation. So this device here, here you want to figure out the scale. So let's kind of take a look at what I chose here. So I did the 1 and the 0.5 and I subtracted it. And then you count. So this is line 0 and then 1, 2, 3, 4, 5. There's 5 lines. So you pick 2 marked lines, you subtract them, and then you take your subtraction over the number of lines, type that carefully into your calculator, and it's going up by 0.1. And it is going up by 0.1 centimeters since this device is marked. And you can always check. So if you did your scale correctly, you can always check your work and by counting up by that counting unit. So 0.5, this would be 0.6, 0.7, 0.8, 0.9, 1, 0.0. So if your scale is correct, then counting by it should lead you to the next marked line and it should match. So here, the precision, all right, the scale now is in the tenths place. So if we do our little placeholders, so this is where the marks are. The marks are going up by 0.1. We can see these, which means we can estimate every measurement on this device to the hundredths place. That would be our precision. So if I asked you like, what is the precision on this? It's to the hundredths place, which means every single measurement would always go to the hundredths place. So when I'm making this measurement, I can see 1.0, 1.1, 1.2. It looks like it's in between 1.2 and 1.3. It kind of looks like it's halfway in between. So I did 1.25. If you thought it was like a little bit more, maybe 1.26, but it's an estimate. 1.24, 1.26 would also be fine. And then make sure you have centimeters on there for the unit. So that's making a correct measurement. Every single measurement on something that ends in the tenths place should be estimate to the hundredths. Okay, this third one, and this is where again, like you want to try and make the measurement, pause the video, and then see what you have. So this one, you got 28, 29. I chose 30 and 29 as my 2 marked lines and subtracted them. That's 1. And then I counted the lines. So this is line 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So again, usually it's 5 or 10 lines. And so then I'm going to take 1 divided by the 10, and that's where you get 0.1. And this doesn't have like a milliliters or liters or anything. So I'm just going to put units. So that's the scale. The scale goes up by 0.1. Which then means, okay, the scale is to the tenths place. So this is just like the last ruler that we did. So the marks are here. This is what we can see. And so we estimate to the hundredths place. So the precision of this device is to the hundredths place. Now, this is at 28.1, 2, 3, 4, 5, 6, 7, 8. It's sitting exactly at 28.8. Like we are certain of that because it's sitting, but it looks like it's sitting right on the line. So because that line already represents 28.8, our estimate here, we put 0. We put centimeters, or no, units, not centimeters, it doesn't say. So it falls on the 28.8. The 28.80, the last number shows what we are certain of if it falls on a line. So that's why it's really important to know what the line represents, because if a mark or if a measurement falls on the line, then you have to know how many zeros to place. Usually it's just 1 more. But let's just say, because this is the type that students get wrong, okay? What if the measurement, the line, the marked line was my red line, it was right on 29, okay? The scale of this device has not changed. Like, it's going up by 0.1. So that line, even though, yes, it says 29, represents 29.0. Like, we are certain that is the marks, okay? That is the scale. Like that, if it falls on the line, represents that, which means if it fell right on 29, we would estimate, we thought it was exactly at 29.0, we'd say 29.00, because we have to estimate to the hundredths place on every single measurement. So if it fell on like any other line, like 27.9, okay, we'd say 27.90. If it was at 27.8, we'd say 27.80, that's our estimate. If it fell on this 28, we'd say 28.00. Notice all of, like, if it was at 28.1, 28.10, like every single measurement on this device is going to go to the hundredths place. Now, usually students don't have issue, like if it was like here, this purple line, you know, it's 28.5, and let's just say 555, it's right in the middle, okay? Units for all of these. Because you're estimating, you already know it's 25.5, it's in between the 5 and the 6, so then you're estimating. But it does not matter where the line falls, where the mark falls, every single measurement of something that has a scale to the tenths place, you need to estimate to the hundredths, okay? So on the remainder of these, okay, you are gonna go through the process and make your measurements. And I recommend pausing the video because I'm going to put up the answers here as soon as you unpause it. Okay, so if you've unpaused it, this first one, you've got 25, 6, 7. So it's going up. The scale is going up by ones, which means the precision is 0.1, or you've got ones, and then this is the tenths. So this would be 27.7 centimeters. And if you have like 27.6 or 8 there, that's fine. I'm estimating that last one, but we would for sure say 27. This next one, the scale is also going up by ones. Which means the precision, everything on this is to the tenths place. So here you've got 15, 16, 17. So we're certain that it's between 17 and 18. I'd say 17.8 centimeters there. So you have 17.7, that's also fine. For the next one, here, this is also going up by ones. And that means that our precision is to the tenths place. And so every single mark, like, we can see this is the marks. And so we have to estimate here for every single measurement on this device. And it does have units, milliliters. So this line represents 40.0. And that's 41, 42. So this is 41. Sorry, this line represents just 40. So if it was on that line, it'd be 40.0. But that line, it's right on 42. We're certain of that. And then we would say, because it's exactly on that, 40.0 milliliters. Now, if you said 42.1 milliliters, because maybe you think it's slightly above, that's fine. Either one would be good. For this one, here again, going up by ones, and so the precision is to the tenths. So we've got 5, 6, 7. So that line represents 7. So I would say 7.0 centimeters. Notice it's just one past, because this is not going up by oh wait, hold on. No, this is not going up by ones. Okay, hold up. Let's actually do the process for this. Okay, so two marked lines, 5 and 0. So 5 minus 0 is 5. And we've got 10 lines here. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 lines. So 5 divided by 10 is 0.5. Okay, so the scale on this is 0.5 or to the tenths. So our precision is to the hundredths place. So that means that this line, so represents, this is 2.5, this is 3.0, this line represents 3.5. So we would say 3.50 since it's on the line. So there's a good example of me rushing a little bit and not doing the full process because we had a bunch of ones, and so I thought this was ones too, but it's actually 0.5. So there, every single line should be measured to the hundredths place. After you've done this, you then have a practice worksheet for you to kind of practice some more, and then just really get good at making measurements on rulers, graduated cylinders, and thermometers are the big three. So, all right, hope this video is helpful.